The event will start in 10 minutes. Please take your seats and remember to turn off your mobile phones or switch to silent mode. Thank you. Good morning, ladies and gentlemen. My name is Gina. I'm your today's host, and I'm very honored to welcome all of you to the 2022 EE Tech Summit. So first of all, in the very beginning, we are very delighted to invite Ambassador Yu Xin, Chairman and President TAISE. He is going to share with us about the topic of roles of technologies in the transition to net zero. So please give a round of applause. Welcome.
Distinguished guests, ladies and gentlemen, good morning. It is my great pleasure to have a chance to talk about the roles of the technologies in the transition to net zero. I'm not going to do detail about the technology. I'd like to talk about the role of the engineers and the scientists, especially in these golden days for the transition. 2015 is a milestone year. In that year, there are two important agreements was passed in the United Nations. The first one is Paris Agreement for the United Nations Framework on Climate Change Conference. In that conference, we passed the important target. That is, the rising temperature for the world is no longer allowed to more than 2 degrees compared with the industrial era. It's better to go to about 1.5. Today, I think most people understand that is 1.5. We are no longer talk about 2 degrees. The second agreement is that the 2030 agenda for Sustainable Development Goals. Both two agreements has very important key idea. It's transforming the world. The whole world will be transformed in the next about 30 years. So after that, Taiwan in this year, in the last March, passed up the Taiwan's 4 major transitions. In order to have the net zero transitions, our government is not last March passed the 4 transition strategies and the governance. The 4 transformations, including the energy transition, production transition, life transition, and also social transition. And it's very important based on the 2 important foundations. The first foundation is technology. The second one is for the legislation. So today we talk about technology. Actually, for those 4 transitions, technology plays 4 different roles. And it's also very basic and indispensable. Without technology, there's no chance for transition. So next one, we talk about energy transition. For the energy transition, tech breakthrough is a key to the zero emission. If you look at about the 2019 compared with 2050s, you will see that no matter how we work hard, we still cannot have the emission reduction to 0. We need some offset. So by the 2050, we have two important carbon sink. One is a negative emission technology, the CCUS or CCSU, carbon capture, storage, and utility. Another one is from the forestry. And another one is very important is that hydrogen energy is a necessity and is basic for the energy transition. However, we just look about the two important technology. One is hydrogen energy. The other one is for the CCSU or CCUS. So far, those two still cannot have the commercially profitable scale. So it still takes a long time to reach that. If the people ask, is that possible for the government to finish this project by 2050? I think we check many, we have the public survey about this transition with the general public. More than 80% of people, they do not believe that we can reach these goals. The importance and the key part is that technology is available or not available. So in next 30 years, I think it's the best golden times for scientists and engineers. It's the best time now because huge amount of the government budget and the industrial expenditure we spend on this one. For instance, we like to take about this one is checked from the Goldman Sachs. They has a prediction forecast about in the next 10 years, by the 2030s, the whole world will spend about 3 trillion on the energy transition, especially for different energy investment. For instance, we have the carbon capture utility. We spend about 900 billion US dollars. About 90 billion US dollars. That's tremendous amount of money we spend with the different countries and the government. Even in Taiwan, government already allocated some money for the CCSU, although that number is not too big. However, the whole world is concerned, huge amount, not only just of CCSU, for all the different technologies I just put on this PPT. The next one, not only just for the energy technology, but also for the infrastructure and the water purification. Then we spend about, for instance, for the water, we spend about 0.5 trillion, and for infrastructure, 2.5 trillion. That means still many technology is not available today. So we got to have spent effort, energy on the new kind of technology in the next 10 years for the net zero approach. If you think that spend too much money, we don't have so much money for this one. However, not every one is just a cost and no returns. Actually, it's a tremendous business opportunity for next 10 years, 30 years. For instance, by the McKinsey's prediction, all the different kind of technologies will be available and also in practice. For most of them, we check about how much carbon reduction under 100 US dollars. Because we also check that for the carbon credit you want to buy, right now most of the carbon credit is around 70 or 80 US dollars in European ETS. So 100 actually is quite a reasonable price. Even that, you can see that half of them actually is negative investment. That means you can reduce a huge amount of carbon emission. However, after 5 years, you can recover all the investment. For instance, for lighting, or air conditioning, or different kind of the investment, you can easily reduce and also recover all the investment. That's why in next 10 years, 20 years, it's also opened a very good chance for the engineers and the scientists. The next one, I'd like to talk about Taiwan's future. The first one talk energy transition. Next one is talk about industrial transition. Because so far, Taiwan's industrial production competitiveness is quite strong in the world. However, the four major items is very important for next few years. The first one is from the major carbon emission industries, like steel, like petrochemical, like fertilizer, and for the cement. The second one is for the supply chain, because Taiwan is one of the most supply chain in the world. The supply chain companies right now is face very high demand from their brand name companies. For instance, Apple, Microsoft, they ask them to use about 100% about the green electricity by 2030. So reduction of the emission is most important. Then second, to find the green electricity. So green electricity generation in Taiwan now is the #1 challenge for the export-oriented electronics. The third one is for the transportation sectors. Taiwan is the highest density of the most motorcycles in the world. We have more than 7 million motorcycles that produce a lot amount of the air pollutions and the CO2. So Taiwan now, I think, have the best chance to have leading the world in the electronic motorcycles. Although we do not have major manufacturing for automobiles. However, for the next electronic cars, Taiwan also stands a very good chance, because most about the parts for many big companies, including the Teslas, they're all produced in Taiwan. So Taiwan stands a very good chance for the automobiles, electronics, electric car. Then for the construction sectors, that is the weak point for Taiwan, because most houses in Taiwan now is old houses. For instance, in Taipei, you see most of them, the houses is more than 30 years old. So we need new buildings. However, the new buildings must have very high standard for the carbon emissions, because more than 1/3 of the carbon emissions from buildings. And right now, our technologies and engineering capability for reducing the building emission in Taiwan is still have a lot of work to do. And besides that, retrofit of the old houses, that's also a huge amount of business in the next 30 years, because old buildings, you cannot just simply destroy it. You need to retrofit. That's huge amount of technology in how to retrofit about old houses. The next one is that we talk about energy, then we talk industrial transition. The important is that really you have changed or not? So greenwash now became the fundamental problem around the world. And in the last week in Egypt, the United Nations have the COP27 in Egypt. They have very important announcement that is zero tolerance for greenwash, especially announced by the Secretary General of the United Nations. He says that we must have the zero tolerance for the net zero greenwashing. Today's expert group report is how to guide to ensure the credible, accountable net zero pledges. Accountable, credible. How to reach that is monitoring. How to monitor is high tech. Without high tech, you cannot monitor all the carbon emissions. So even same as in the COP27, announced by the former Vice President Al Gore of the United States. They announced that for the climate trace, it's very good tool to monitoring all around the world about the carbon emissions. So transparency and integrity are the foundations of successful global corporations for combat carbon emissions. as I just mentioned, that the only way to reach that is through technology. By using the technologies like artificial intelligence and the machine learning to analyze the data from more than 300 satellites, more than 11,100 sensors, and the numerous additional sources of emission information from all over the world. A model can be built to estimate the emissions from the sources. This allows independent, transparent, and timely carbon emission monitoring system. So you have nowhere to hide about your emission. So this one, in the next few years, become very big business for monitoring system. So ICT is the most important industrial strength for Taiwan. And ICT is very good for carbon emission reduction because according to the statistics and the research report, ICT industry spend about 2% about carbon emission for the whole world. However, the ICT has a leverage. If you properly use ICT, you can reduce about approximately 20% about industrial carbon emission. That's huge leverage. So that is the best chance for Taiwan using the ICT technology to reduce carbon emission for the world. And for the AI, according to this report, the leveraging AI to tackle the carbon emission, in the before 2030s, the contribution of AI to the environmental sustainability, we can increase about the GDP plus about a 4.4% GDP increase. That means about 5.2 trillion US dollars. And then we can reduce about 4% about the global warming gas. This is about minus 2.4 billion CO2 tons. That's a huge amount about the carbon emission. At the meantime, we can increase the job about 1%. That means about 38 million people's job. So ICT and the AI stand a very good chance in the next 10 years for net zero approach. The next one is that we talk about energy transition, we talk about the industrial transition. However, two important. One is the social transition. We need a fair social transition. We want to leave no one behind. For instance, technology industry in Taiwan. You remember that? If you remember that. Technology is high profit, also the high pollution, high carbon emission, high water consumption, high CO2 emission. So at the same time, it must be fair to reduce amount of the emission, to properly use the water resources. That became a fair society. The second one is that for the natural resources for Taiwan, Taiwan is a country without any natural resources. So we provide very good electricity and water, or limited amount. So we must, as a social responsibility for the big companies, the big industry, must carefully ask for the use about such kind of energy, electricity. For instance, in Taiwan this year, if you ask a Thai Power company, this year Thai Power lost about 200 billion NT in operation. It's not fair to most about the citizens, because if the Thai Power lost the money, who pays for that? That's the general publics. So how do you become the fair and good social transition is very important. Keep in mind about engineers and scientists. Is be very careful. And in next couple of years, for instance, 3 years ago, in Taiwan, we had a public survey about renewable energy in Taiwan. More than 80% about the people agree and support for the renewable energy transition. And this year, we checked that one, reduced about 5 to 6%. You know why? Because some people quite worry about environmental negative impact. For instance, noise or the recycling about the waste materials from PV, etc. So this is very important. Finally, I just one word to conclude my speech, is that also the civil engagement is very important, because you need to have some transition change about the behavior. And for engineer and the scientists must be careful about how to introduce a new technology and invite the public to join together to change lifestyle. For instance, for the recycling, or for the circular economy, you need to change the people's behavior. And how to change the people's behavior, it takes a very difficult, long time to educate the public. So it's very important. So my conclusion is that we have 4 major transitions in next 30 years. The technology is the most important tools to complete. However, with the 4 different transitions, the technology have 4 different roles. We must be very carefully and use it and to finish our transition to year 2050. Thank you.
Thanks, Mr. Yoxing. So now, following, we will introduce the Zhu Zhenhu, the Senior Vice President, ETRI, and he's going to share with us about the topic of development of green and smart vehicle technology. So please give a round of applause. Let's welcome.
Okay, Ambassador Jen and Grace, and ladies and gentlemen, it's been my great honor to deliver a speech in this very exciting event. The topic of my talk is about the development of green and intelligent vehicle technology. I'm from ETRI. Okay, here this is an outline of my talk. So I will talk about why I select this topic for today's speech. Then I will cover a little bit about the technology involved in this area, and finally a concluding remark. So first I would like to give a definition of the title I have today. The target is on the vehicles, okay? I think for our effort to reach the zero carbon emission, I think vehicle is the most important target. The vehicle transport human goods and functional payloads. It's closely related to our daily life. However, the vehicle is experiencing 2 major trends. First one is green energy. Most of our vehicles currently are propelled by fossil fuel energy. So we are going to eliminate that. It's a huge effort. So we want to reach the zero emission and the zero pollution. So once the vehicle is electrified, it's naturally now will allow a lot of ICT, intelligent technology, to be introduced into vehicle. So in other words, intelligence will be inevitable. It's a trend following our effort to reach the green energy of the vehicle operation. Now, the vehicle technologies is interdisciplinary area. It needs a collaboration among electrical, electronic, mechanical, material, and the information and communication areas. So it's an area that requires a lot of joint efforts among all the people. Okay. Now, this slide shows the driving force of the global EV, electric vehicle development. Sure, I think everybody knows that we want to reduce the average temperature rise of the Earth. So there are Paris agreements signed by many countries. Okay, and we have some goals. For example, reduce the carbon emission from 2015 to 2025 by 40%. And the largest carbon CO2 emission contribute from the vehicle. Okay, so for example, European has a very stringent standard for vehicle emission, 50 grams per kilometer CO2 emission for the vehicle. So I think in the future, I don't think it's possible to sell the fossil vehicle in Europe. Okay. That's for the government and the regulation side. But in terms of business, people are concerned, is EV profitable more than the fossil fuel vehicle? Here, this is, I think from the survey that if you sell a vehicle in electrified version, the gross margin is higher than a fossil fuel vehicle. And from the consumer perspective, if you own an EV, the annual maintenance cost or the maintenance cost per mile for fossil vehicle is 0.1 US dollars, but for EV it's 0.06 US dollars. So from these 2 points, I think the EV is unstoppable trend, okay, either from business or from the consumer. Okay. Now, as I mentioned, that once the vehicle is completely electrified, it's naturally that people will introduce a lot of ICT technology into the vehicle. And as a consequence, the vehicle will become the major infrastructure of our future smart city. So this slide shows that the autonomous driving vehicle will affect the area like logistics. So there are a lot of companies already develop the self-driving trucks for long-haul freight, okay? And also to have a self-driving vehicle to serve as a taxi, robo-taxi, and also the public transportation like unmanned bus, okay? And there are other implications of the technology. For example, we can apply the self-driving technology to community patrol, traffic violation detection, and other things like agriculture automation. Particularly agricultural automation or electrification is a large area that currently they are not emphasized in the technology roadmap. Most of the agricultural machines today are also burn fossil fuel. So it's very important to electrify all the agriculture machines. That will be a big, huge effort in the future. So because as I mentioned, these area involve interdisciplinary research. So in E3, we have established a strategy promotion office. It's called Intelligent and Green Vehicle Promotion Office, IGV office. And underneath the office, we group together all our research effort in different business units. So we have 7 subgroups in unmanned aerial vehicle, self-driving vehicle, railway transit vehicles, green vehicles, automotive electronics, AMR, that stands for Autonomous Mobile Robot, and ICT service. So today I would like to cover self-driving vehicle and the green vehicles. And And by the way, the office also established some industrial alliance. For example, we have the Taiwan Electric Vehicle Power Supplement Industry Technology Promotion Alliance. In this alliance, we try to establish the charging standards for all the EV in the future. I will talk about that later. Okay. It is predicted that EV sales will surpass fossil vehicles around 2035 to 2040. Okay, and in terms of a business scale, in the future, the EV business scale is about 2.3 times than the cell phone. I think everybody knows that the cell phone is a major economic driver for today's economy. But in the future, the EV will have a larger scope of revenue than the cell phone. So that's why a lot of business people, they have their eyes and the investments on the EV, okay? However, to implement EV in our society, the charging infrastructure is the key, okay? In 2020, we only have 1.3 million charging stations in the world. But however, that is already a very fast-growing business, 30% growth rate compared to 2019, okay? It is estimated that to 2030, the overall market size of the charging infrastructure is $119.5 billion US, and with 30% annual growth. And the European Council suggests that in order for the EV to be popular, it is necessary that every 60 kilometers, you need to have a charging infrastructure. And we are still way behind that. And in the United States, additional 1.7 million EVSE has to be installed in the future. Okay. Now, within that establishment, I think one of the important aspects is that all the EVSE has to be network connected. By connecting all the charging equipment in the through the network, we can have a better management of our energy supply to EV. Okay, so the following the EV development, as I said, there will be a development in the autonomous driving vehicle, or we call intelligent vehicle. Okay, and there are a lot of forecasts of this market. But it's not happening so fast right now because there are a lot of safety concerns that people are afraid of the unmanned vehicle running on the street may have safety threat to our pedestrians or other vehicles. However, people still believe that in the future, this technology will be implemented in our society. So as you can see that the forecast of the market size is very large. For example, in 2030, it's estimated that $420 billion US. And if you consider the mobility as a service, the market size is even larger, okay? But it's estimated that Mars, once the vehicle drives by itself, the mobility as a service will be a booming market in the future. By the way, a lot of energy is wasted on the road because of the human driver, because some drivers do not follow the traffic rules, or they have some drastic maneuver of the vehicles. However, if we have the vehicle drive by itself, the vehicle can be driven very efficiently. So in other words, by implementing the intelligent technology, it is also likely to reduce our energy usage of the vehicles. Now here, this slide shows that the worldwide effort to push the technology to the market. Okay, we have on the top of the graph, the 3 major technology driver, Mobileye, NVIDIA, Qualcomm. They also have designed a powerful chip. And the chip is implemented by many software providers or intelligence technology providers like Continental, Bosch, and some others. And those technologies are introduced into the vehicle company, who also establish self-driving fleet. For example, GM, the Cruise, Volkswagen, Travel Assist. And within that vehicle, the most important components are sensors. Okay, and the sensors occupy the largest cost of this vehicle. So it will be a great chance, especially for Taiwan, because those sensors and the computing chips, communication chips within the vehicle are strengths of our ICT industry. Okay. Once the EV is deployed, there are a lot of applications that people are thinking about. For example, environmental service, street sweeping, even the garbage collection can be automated. Okay, and closed area transportation, like in airport, seaport, or mining. And the freight truck, of course, we can have the autonomous driving truck running in between warehouse. One of the aspects is that during the morning, between 1 a.m. to around 5 p.m., 5 a.m., our road is not occupied. So if you are a businessman, you know that you construct a road, you need to put a lot of investments. However, for every day you have around 5 hours, the road, the availability of the road is almost zero. Okay, so within that time, we can have the self-driving trucks running on the road to fully utilize our investment. Okay, so this slide shows that in E3, we know that intelligent technology is going to change a lot of our product in the industry. Therefore, our intelligent technology is introduced in 3 areas. One is sensing, the other one is urban intelligence, and the third one is efficient industrial operation. Okay, and today's talk is covered within the our effort to building the urban intelligence. In other words, the autonomous mobility. Okay, now quickly I'll go through some important technology development of the EV and the autonomous driving vehicles. Okay, this slide shows that our effort in E3, but it also reflects how our industry in Taiwan is working on this very exciting area. So we have EV system. I think many people know that the Hon Hai already established alliance MIH. It covers a lot of areas, and a lot of companies join that consortium. And so in E3, we try to establish the vehicle engineering to design the whole EV and work with the Hon Hai and the MIH. Of course, we have self-driving technology, by-wire control, EV chassis, powertrain, gearbox, and lastly, the most important one, how do we make the charging infrastructure, okay? So our effort is try to help Taiwan to establish the supply chain. So a lot of companies, as you guys can see from the slides, they are all working on this area. Okay, once we replace the engine with the motor, there are a lot of new ideas can be implemented to the vehicle. And one of the most important trend is how
how do we put things together as a small, compact, and integrated propulsion system. So in the future, I think we will combine motors, inverters, gearbox, onboard charging, everything within a very complex module. And there are already companies worldwide. They are working on this area, and this is a very important technology to put things together. I think the thermal engineering and a lot of electronic design has to be implemented, or some advanced research has to be carried out in order to have a very compact propulsion system. This is the heart of the EV. And X-by-wire, because of the self-driving development. So the X-by-wire technology is also important. We have the by-wire control in steering, braking, and the throttle. And this technology has to take care of the vehicle dynamics, and it has to run on all weather conditions. Okay. In ITRI, we also establish how to design those X-by-wire system, and I think this is also an important business area for our a lot of our industries. And the next one is a battery. This is also an important technology in EV. And I think currently that everybody is talking about solid-state battery, because the battery, the safety of the battery is a very great concern. So in order to reduce the dendrite damage of the battery layer, we need to have some technology introduced in order for the battery to be fail-safe even under crash. Okay. And I think for the community here, it's very important to know that people are curious that in the future, how will the electrical and the electronic infrastructure in vehicle are changed? I think the driving force is that we would like to reduce the wire harness. Currently, for fossil vehicle, the wire harness, the wire length within a vehicle is around 4 kilometers. Okay, 4,000 meters. Okay, and that create a lot of robustness problem or stability problem. Okay, so people try to reduce the length of the wire. Okay, and also because of the autonomous driving, there are a lot of needs for communication bandwidth and the data volume within the vehicle, not outside the vehicle. So, and also the increase the number of sensors will also increase the wire length. So the overall trend is try to reduce that in order to have a robust vehicle design. So people are thinking about different type of electronic and electrical structure, and that will affect how will people design the ICs, and also design the communications within the vehicle. And this shows the ecosystem or the technology items for the autonomous driving. And I think the world right now is trying to figure out how can we establish the supply chain. So a lot of companies in Taiwan also try to see how can they position themselves in this self-driving supply chain, okay, providing the technology that's needed for the customers. Okay, this is the last slide, and I think this is the most important one. As I said, the energy supply for the EV is very important, so we have several aspects from the government, economy, society, and the technology. Particularly, I think that currently the driving force is on the government, okay? So government has to give some incentive program and also put investments for the society to establish the charging infrastructure. Without the charging infrastructure, it's not going to work, right? Because people are afraid of, we call charging anxiety, okay? And on the other hand, there are a lot of new business ideas. Okay, for example, one of the interesting ideas that maybe in the future, the coffee shop will have the charging infrastructure. So you can drive your vehicle to charge in the coffee shop, but if you buy a coffee, your charging will be free. Okay, so there are new ideas that develop in the market, and I think that's going to even change our lifestyle. So to end my talk, there are three things to take away. The first is the market of EV, intelligent vehicle, and the self-driving vehicle are pushed forward by need of pollution reduction, carbon neutrality, transportation efficiency, and safety. Okay. The second one is the vehicle industry is experiencing drastic change with many opportunities in new technology and business models. Okay. The third one is that I did not have time to talk about that. If we have many EV connected to the charging network and the charging is connected to our grid, those batteries in the vehicle will become a very large buffering for our power utility grid. So that will affect our power generation, dispatch, and the usage. This is another revolution that is kick-started by the EV deployment. Thank you very much.
Thanks, Mr. Zhu Shenhu. Thank you so much. And following, we are going to invite Dr. John Lee, the Managing Director of Merck Group in Taiwan. He is going to share with us about the topic of Merck's pathway to sustainability with science and technology. So please give a round of applause. Let's welcome.
All right, Grace, Ambassador Jen, ladies and gentlemen, morning. This is John. I guess the file is not yet changed, but anyway, that's all right. My name is John Lee. I'm the Managing Director of Merck Group in Taiwan. It's my great honor that I would have this opportunity to talk with you about the sustainability plan at Merck and the green technology associated with. I think sustainability is no longer just an advocacy. It's a serious task that we need to jointly tackle. And then the window of opportunity is getting slimmer and narrower. In the business world, we all talk about the plan B as a backup. But in real life, we do not have the planet B for us. So I particularly like this slide. We don't have the planet B. We all live on this planet. Before I dive into the sustainability topic, let me give you a very brief intro to the company that I'm working for. Merck, we regard ourselves as a vibrant science and technology company. Hopefully, in the following slides, I will provide you some of the proof points. Founded in 1668, so it's the 17th century, that starting with the Angel Pharmacy in Darmstadt, Germany. Darmstadt is a small town, around like 20 miles south to Frankfurt. That nowadays, Merck is the company with the longest history in chemical and pharmaceutical industries so far. And then at Merck, safety and quality are the two guiding principles for all the Merck employees. After World War I, that Merck actually, afterward, Germany actually was defeated. So most of the German companies, they lost their properties, including trademark, IP, and everything, all the assets in North America. And Merck is no exception. So our US branch office, Merck & Co., has been independent from our headquarters, Merck headquarters, and become a US company. So Merck, that we could only use at EMD, Emmanuel Merck Darmstadt, as a trademark marketing in North America. On the other hand, Merck & Co., they could only call themselves Merck Sharp & Dohme outside of North America. Nevertheless, over the more than 350 years of the history, Merck has been developed itself from a local pharmacy into nowadays a multinational company covering 66 countries with more than 60,000 employees worldwide. And this is the fact sheets provide you some of the key numbers for Merck. Merck definitely, looking at the number, the revenue that we achieved last year is a little less than 20 billion euros. Merck definitely is not, by number, it's not the largest company in the world. But if you look at our R&D investment last year, it's more than 12% of our external revenue invested in R&D. This is a huge number. And this is one of the proof points that we claim ourselves a science and technology company. We invest a lot in R&D. And joining Merck, on the first day, the very first day we joined Merck, that we need to face our counterpart, our colleagues from 142 different nationalities. So join Merck, that diversity, equity, inclusion, the D&I, is already embedded in our gene. The company now has been developed into 3 different business sectors, namely healthcare, life science, and electronics. Each business sectors, they will have their own focus areas to target, for example, the oncology, immuno-oncology, or mRNA upstream materials development and technology testing equipment. In electronics, we focus on semiconductor and displays, and also surface solutions as well. So these 3 business sectors, they are well in line with the mega trend, tap into the market mega trend, but all together, we serve one corporate purpose, that is to dedicate it to human progress. All the work we do, that we point to the human progress. That's very important. Now, coming to Merck's sustainability topic, that is so vital. The position of sustainability is so high that at Merck, our CEO, Dr. Belén Galijo, mentioned very, very specifically, sustainability is so crucial and vital to our business and to our operation overall. As a matter of fact, Merck, with its 354 years of the history itself, is already a very good example for sustainability. And we do committed ourselves to 3 overall goals. By 2030, so not far from now, only 8 years, that we want to achieve, the human progress of more than 1 billion people with our sustainable science and technology. Yeah. And then at the same year, we would like to integrate the sustainability into our value chains, including our suppliers. Yeah. And then there's another very aggressive goal. 10 years later, 2040, that Merck overall, globally, we would like to achieve climate neutrality. So, and then these 3 overall goals cover 5 different UN SDG goals. Some of the speakers already mentioned the cell phone. So let me use the cell phone. Everybody, that we all have the cell phone. We use it every day. I take this as one example. The carbon emission by one cell phone throughout its life cycle, the usage only account for 20%, but the production actually account for another 80%. So up from the raw materials, the materials, and also the device productions, the entire value chain, actually, we need to be responsible for this 80%. I think this is extremely important. And then the device become more sophisticated, more complicated, and then our dependence on the advanced node of the semiconductor become heavier as time goes by. So in the advanced nodes, it will consume 2.5 times more of the roughly 2.5 times of the water, and 2.5 times more of the greenhouse gas emission, and then 3.5 times of the water compared to the mature node. So we need to think about how we could reduce that. Merck, as one of the key material supplier in the upstream semiconductor. We're thinking that how we could do this, how we could help our customer to improve. If I somehow simplify the over 300 steps of the wafer process in the middle, that you see the pink circles, simplify them into the 6 key steps, namely doping, patterning, deposition, planarization, etching, and cleaning, plus the downstream packaging, these 7 key steps. Merck is one of the very few suppliers in the world, in the semiconductor industries, that we could provide the key technology and materials to these 7 key steps. So we think we are providing the material with highest purity, highest efficiency to help our customer improve their production efficiencies, their yield. And then some of this product produced, there has to be safeguarded in a special design container, ship it to our customer, plug into the tool for the process, for the wafer processing. And that is done by our DSNS, Delivery System and Services. At the bottom of the slide, you see the light blue circles. That is also the service we provided. And in order to help improve the IC design hit rate before handing over into the IC fabrications, we have a unit called intermolecular doing the prototyping and testing to help them increase the hit rate. So overall, Merck will thinking to provide an end-to-end service and technology to help the semiconductor industries to reduce the scrap, to improve the efficiency, to improve the yield rate. Ambassador Jen talking about the supply chain, and I cannot agree more. Supply chain is also one of the very important carbon emission elements. So we're thinking that for all these key materials that I just mentioned to you, that if I all import those from overseas, they will also create a lot of carbon emission. So end of last year, Merck announced a huge investment in Taiwan worth for 500 million euro. They will build a mega site in Taiwan to produce the materials that I just mentioned to you in previous slides. And then by localize one product line in Taiwan, that we estimate we could reduce 800 tons of carbon emission in Taiwan. And imagine that how many product lines we're going to localize here in Taiwan. We are hoping that by building this mega site, we contribute a lot to the carbon emission reduction by reducing the logistics. And nevertheless, we will not miss the opportunity to make our building greener. So you see that we will adopt the solar cells panels, LEED certificates, and recycling all the waters and so forth and so on and so forth. For some of the product that we cannot locally produce, that we need to ship from overseas, that we decided to largely use the ocean shipment instead of air. So we estimate next year, 2023, that we're going to reduce, 90% of our healthcare product will all shipped by ocean shipment. And then we target to reduce 10,000 tons of the carbon emission by only doing this. So later I'm going to introduce some of the, sorry, let me run the time. I will going to introduce some of the greener technology that associate with the sustainability. Ambassador Jen also mentioned about the technology. Yeah, I like to echo what you just say. I think that is important. Trying to achieve sustainability is not ask us to go back to the Stone Age, but nevertheless, the digital living needs to advance. So in order to achieve this, the only way is to advance the technology, science and technology. We use science and technology to address the sustainability topic. And this is the example. If you Google it, smart window, and then you probably get more than 1,000 hits. Most of the smart window that give you the color privacy, change the color, or some of the thermal energy being reflected to your neighbors. But the smart window here that developed by Merck, that we insert the liquid crystal into the window. We call it liquid crystal windows in abbreviation of LCW. By controlling the orientation of the liquid crystal molecules, that we could control the intensity of the light coming into the room. So let me give you, there's no animation, I just show you that now the liquid crystal window oriented perpendicular to the orient perpendicular, there's no light coming in, so that the window becomes black. So we could actually modulate the light. We could modulate, by changing the orientation of the liquid crystal molecules, we could modulate the light coming into the room, so that the interior, you could reduce the lighting, you could reduce the use of the AC. And actually, the installation of LC windows is not only in Europe. This is the old slide. We already have successfully installed LC window at our facility in Taiwan. So if any one of the audience, you are interested to visit our facility, the LC window, feel free to contact us. At our Taoyuan facility that we already installed the LC window, that have already become, we just finished the installation 2 weeks ago, and it already become the most favorite spot by our employees. Lithography process actually is being widely used in semiconductor, in wafer, in panel, and even in printed circuit board. And photoresist is largely used in lithography process. NMP, the N-methylpyridine, is a highly polar solvent that has been widely used as a remover in the lithography process. Yeah. And Merck has been developing a photoresist remover, or some people call it stripper, without containing the NMP. So, and then the end result is that the process time could be cut half, and you know, the efficiency is higher, and we could even extend the filter time, filter's lifetime. We understand in order to achieve the sustainability, we cannot do it alone by Merck. So we work together with one of our major customers, Micron, that we together joint develop the etching gas solution containing much lower greenhouse potential, the greenhouse potential gas. I think we are trying to promote this concept together with our customers. They echo what I just mentioned. We would like to integrate the sustainability into our value chain to achieve our sustainability goal. Merck is one of the largest chemical companies in the world. We already developed more than 1,400 green chemicals in 10 different categories. These green products, they're either coming from the natural source or they are biodegradable. So after use, they come back to the nature without giving too much burden to the environment. And within Merck, we have a principle called design for sustainability. And I'm giving you 2 examples out from these 1,400 green products. Styrene is used to replace the polar solvent, the DMF, dimethyl formaldehyde, and also the NMP that I just mentioned to you. These 2 polar solvent has been widely used in electronic industries. And the styrene has been introduced to some of our customers, been testing. In some of the industries, they will use a sweet potato and acetone to convert starch into sugar. Merck developed an enzyme called beta amylase that you could only use this without 1 drop of acetone, no electricity needed, and then you could use less raw material to achieve the same purpose. So the science and technology really works. I just want to mention to you. I want to prove to you. And we not only doing this, again, we offer a weight-based formula. We call it DOSEN, also coming from our Design for Sustainability platform. This is a software that will allow our customer to estimate how much carbon footprint they will produce by using this chemical or these reactions. So this is our a little contribution to the overall society, that we are not only providing the raw material, the chemical to our customers, but also bring them the concept of sustainability. And this is a slide actually very difficult to most of the managing directors of Merck subsidiary around the world, because we are being asked by our headquarters that we need to have the green substitution in a respective country as long as there's any green alternatives available in our production, in our lab. So this is our commitment. Regardless, it could be the higher price, higher cost, but we just need to use it. We understand that the sustainability could not only achieve by chemically, physically, but data and digitalization play a very important role. We produce chemicals. In Taiwan, I have 4 facilities, 4 sites. So we're thinking that the smart manufacturing could really help us to reduce the carbon emission. I take one example. This is our Taoyuan site producing liquid crystal, and we designed 3 phases to make our plant completely digitalized. Now we are in between phase 2 and phase 3. Without going into the detail, let me show you some of the current results. So far, we do not use one piece of paper from incoming material to the material being shipped out to the customers. 0 paper needed. And then we integrate more than 200,000 data in our production. And our total savings so far that we estimate is more than €1 million by reducing the scrap due to the human error. And this is exactly because some of the confidentiality, I cannot show you too much detail and the clarity. You see that on the control panel, each production line, the container in each production line could be monitored, digitalized. That you could clearly see from this control panel, knowing that the progress of the production and the use of each vessels, each reactors. We understand the use of this technology could benefit our customers. So we work together with a company called Palantir in California, and jointly develop a platform called Anthenia that we integrate all the data all together to break the silo, to improve the quality, the efficiency, and also perhaps this could be also used to address the logistic issues. And this is my concluding slides, and I like this a lot. I think that this is from the former United Nations Secretary General, Mr. Anand. He mentioned that actually the biggest challenge for us is not sustainability itself, but it's how to take this up and turn it into reality. Thank you.
Thanks, Mr. Zhang Li. Thank you so much. And now we are going to welcome DENWELL, is the Vice President and Chief Technology Officer, Ericsson. He is going to share with us about the topic of breaking the energy curve, build a sustainable network. So please give a round of applause to welcome.
Good morning, ladies and gentlemen. And Ericsson is a Swedish company, okay? So I should greet everybody in Swedish. Tjena, hey, hey. It's not a joke. Swedish really say hello to each other like this in the morning. Okay, so energy efficiency is on top of our agenda and our customer agenda. And this issue together with the demands of increasing capacity needed for the network to address the ever increasing traffic is becoming ever so important. Okay? Today, I'm going to present the breaking energy curve, which is a commitment that have been working together with the customer, our partner, and ecosystem together. United Nations Intergovernmental Panel on Climate Change have issued the 6th report in August 2021. And it declared that human beings are to blame for the worsening stage of the global warming. And there are rapid action need to be taken to cut down greenhouse gas emission to limit that impact. Okay, this comes after about 5 years from 2015's Paris Agreement, right, that everybody come from around the world commit to the Paris Agreement, committing that we should control the global warming well below 2 degrees Celsius, and ideally down to 1.5 degrees Celsius. So this is, but if you think this is what we should do, but is that easy to do? No, it's not really easy to do. Okay, so we talk about that greenhouse gas emission and net zero. If we want to achieve what United Nations have asked everybody and tell everybody how do we control this, for many countries and many industries, that translates to a committed ambition to move to net zero carbon emission by 2050. So what is net zero carbon emission? Well, net zero carbon emission is a stage where every carbon emission emitted, okay, the same amount will be absorbed by atmosphere. Okay, so you may be thinking 2050 is still far away, but reaching net zero by 2015 is not that simple, and it should be done in a progressive way. So, at the first milestone, we set across every industry a target to cut carbon emission by half by 2030. That is a stepping stone that we can move to our ultimate goal, okay? Today, ICT industry is contributing about 1.4% carbon emission for the global emission. Sounds very insignificant, right? But this ICT technology has the potential to enable 15% emission reduction for the adjacent industry, like we show here, like manufacturing and transport. Okay, so what do we do to do that? Well, basically what we do is to control what we have been doing in the past and do it differently so we can actually achieve that. This shows the biggest challenges of the mobile community that we're facing. You know, the energy costs, the energy we use, and the carbon footprint is always a biggest challenge for communication technology. So if you look over 10 years in the past, what have happened, right? Do you know that the traffic volume that we use on the mobile network in the past 10 years increased nearly by 300 times? 300 times, not 3 times. But at the same time, the increase of the energy consumption is actually only 1.6 times. 1.6. It's mainly due to we need to accommodate more users to take care of more traffic, so that we need to add frequency band to use and add more base station so that equipment consume more power. In the meantime, the same period, the 4G population coverage has come from 5% to 86%, which is 17.2 times, as we show. This is give you implications of what have happened in the mobile network. So, let's look at the energy consumptions of the mobile network from a different perspective, which is from generation to another. If you look at the chart we draw on the right, so from the first generation to the fourth generation, okay, the power consumption have a relatively constant increment from generation to another. So you see they come up roughly the same magnitude, right? And it's not difficult to predict that if you implement 5G, the same relative increment will happen in that, okay? So in 2020, we have done an estimation. All the operators around the globe is spending about 25 billion US dollar annually for running the mobile network. Okay? And that cost has been increased, and it will further increase when you implement 5G and further generation that you implement later, because you use more energy. Okay? But in Ericsson, we believe that it is possible to break the energy curve. If we do it in a different approach, we can actually change the trajectories of the energy consumption in the mobile network and become the downward slope green area that we show there. Okay? So we change that, break the energy curve. So how do we do that? Well, we streamline our approach into three major elements. The three major elements are sustainable network evolution, expand and modernize, and operate intelligently. Okay, so the first, sustainable network evolution, what does that mean? That means we have to help our customer, operator customer, to embrace a holistic view for the network planning and operation, so that we can actually plan the network, operate the network, deploy and build the network differently in a very, very low power consumption way. So expand and modernize the network. When we need to bring a new site, when we need to introduce a new technology like 5G, whenever you add 5G to a site, that often involving you adding new frequency. When you adding new frequency band, that means new equipment. More equipment is needed on site. So in order not to increase the power consumption, the existing install base of the equipment need to be modernized so that you use less power. Operate intelligently means leveraging AI and machine learning as well as automation to boost the energy saving. There are software features that we invest to R&D and invented for a customer that can actually do this job very well. Okay? So let me go through all this element one by one so that you will know this is not a corporate propaganda, but the actual work done to achieve this commitment. So start from the top left, sustainable energy evolution. So remember we talked about holistic view. So what do you mean by holistic view? Okay. For the audience who have some age like me, hopefully you still remember when we first implemented 2G in Taiwan, right? So the signal is not very good all the time from place to place, especially indoor. So from time to time, you hold up your mobile phone, going from one corner to another, try to find the best signaling spot. And whenever you close the window, you just close the window, try to get the thing. Remember 泛亚的广告，手机要拜天公. That's what we've been facing, but that is no longer the situation today. So holistic KPI, that means you operate, you plan, you build your network, not just with the traditional KPI, because the traditional KPI is measuring coverage and performance. You also increase other perspectives, like the energy usage and the cost. How do you prolong the hardware life cycle? How do you include renewable energy use? How do you use higher efficiency or operation to do this thing? Okay, so take an example like the radio network. What is a radio network? The radio access network is a component of the mobile network, which is connect your devices to the core network, okay? And so that you can make call, browse internet, watch video. So how do they work? They work by constantly detecting where you are, receiving the signal from your mobile, and also constantly sending signal to your mobile. So by my description, you will easily fill with all the active and passive components that RAN use. RAN is representing 75% of the mobile network power consumption, which is the major power consumption come from. So what can we do for RAN? What can we do for RAN is we measure the correlation between the wanted performance and the power consumption. Also, we measure the traffic volume and the user experience per site over time. So by collecting those data, then we can use that data to do the judgment and lay down the strategy to use the power-saving functionality and feature in the most precise way and a better way, okay? So next, the expansion and monetization. Here are two pictures on this slide. The left-hand side is the site that built in 2010. This site is able to accommodate 2, 3, 4G, okay? So this left-hand side. The right-hand side is the most recent picture. And the right-hand side component is capable of taking all the traffic and the functionality on the left-hand side, then plus 5G, okay? So, you look at it, you start to feel, whoa, yeah, this is much smaller, lighter, and simpler. Right? So what are we witnessing here? We're witnessing the monetization of the site. So by doing that, you'll be able to add 60% more capacity to the site while still reducing the energy, the radio unit you use and the power consumption of the site by 50%. Okay? In addition, this is not the only thing you can do because these are fully automated. So by connected everything and the automation, you can actually do commissioning, maintaining, testing, upgrading, troubleshooting, all the same, remotely. Okay. By doing that remotely, you tremendously reduce the carbon footprint for the field engineer to need to be physically travel to the site. The transport carbon footprint can be removed. All right, last, the third one, the operate intelligently. So operate intelligently is mean leveraging AI and machine learning to boost that energy saving. So let's describe it a little bit, not too technical from left to right. So predicting RAN energy optimization, what is that? What do you mean by that? Well, the technology today, because the traffic will fluctuate or vary from time to time. Sometimes these variations are only down to millisecond level, okay? And from daytime, nighttime, they're all different. Traffics are different. So if you use AI and machine learning, detect and predict, you can actually turn off part of your equipment when they're not in use. And you turn them back when they're needed, right? So you carefully use those power-saving capability to manage the performance you needed. This is what we mean by predict the energy optimization. So the same principle can be applied to the infrastructure energy optimization because then you can collect the data from the infrastructure energy equipment like the climate control unit. So by monitoring and control, you can look at the temperature, the environmental temperature trend, and change the setting of cooling. Or by your equipment heat-resisting performance, then change the cooling because cooling is waste of energy, right? So you can do that. And you can also do site energy profiling by using long period of time collecting the power consumption and the infrastructure performance rating. And you collect all these data to trend, long-term trends, then you can do very important thing, which is the inefficiency root cause analysis, where on this side, after the root cause also those inefficiency. And the last one is the power source optimization. By doing AI and machine learning, you can actually collect data, profile, predict, and even change your diesel engine backup power running time, running hour based on the availability of your renewable energy availability. So you can switch in between, which is AI and machine learning also help you to base on cost, your cost, so that it increase the returns on investments of you to use the renewable energy. And there are features, there are functions that we can use. Like I described, the mobile network actually vary from day to time. Traffic are different. Sometimes here, somebody comes, somebody go, right? So actually, we can leverage that difference and shut off and turn off the component we don't need to use and turn them back on when we need them. And the differences of the energy use between no traffic and full traffic is actually as large as 97%. 97%. That means I only need 3% of the power at the peak time. I only require that to keep the base station alive, okay? So the feature like micro slip transmitter can actually turn off power amplifier, not the entire rail, but the power amplifier when there's nothing to transmit. So the power amplifier is not boosted. Power amplifier is the most power consuming component in the radio unit. And deep sleep. Deep sleeps mean I can actually take the whole MIMO, just take the entire antenna or the sector or the frequency band and just turn it off. And turn it on when I need it, when there's traffic. So that will reduce the power to about 2.7% or 9% compared to the peak power, compared to full load power. So Ericsson's recommendation is to activate all these features and software because they yield the most saving and contribute a lot to the net zero target. Okay, I guess I successfully accelerate my speech so that people still get back to the schedule. So this is my conclusion page. Okay. All right, what have Ericsson done? Ericsson actually committed to be net zero across our value chain by 2040. Okay. So with the first milestone we set is by 2030, all our supply chain and the portfolio we use should be cut the emission by half. And at the same time, our own operation need to be net zero, our own operation, which is category 1, net zero, okay? And we're also aiming to help all our customers. If there is a typical new site to build, we're trying to reduce their energy consumption by 40% between 2021 to 2025. Okay? When the subscription and traffic increase, when the technology generations start to evolve to the next one, we leverage that chance to go through all these 3 approaches that we propose and we dedicatedly working on is to help our customer embrace the holistic view for network planning and operation so they get a sustainable network evolution, and to modernize the existing network while we're scaling up in 5G, and that is exactly what we have done in Taiwan. Okay? And we leverage AI and automate it and boost the energy saving and operate intelligently. That's the major 3 approach. And last but not the least, we share experience with our industrial comrade and the supply chain. So we help each other to meet the carbon emission ambition, zero emission, okay? For the world, for our environment, and for our future generations to come. Thank you.
Thanks, Mix Daniel. Thank you so much.
One last advertisement. There is a QR code on the left. If you are interested in the Ericsson Break the Energy report, use that QR code. Thank you.
Thank you so much. Thank you. The next session will start at 11:10. Please take a short break right now, and please take the time to visit the display area. At the same time, we also provide refreshments when visiting the display area. If you need to subscribe to the magazine, you can scan the QR code on the screen and fill out the subscription form. Please don't leave personal belongings on the seats to avoid loss. Thank you. Ladies and gentlemen, the next session is about to start in 1 minute. Please take your seats and remember to turn off your mobile phones or switch to silent mode. Thank you.